So today is all about how to prove triangles are congruent, and there are 5 ways. So here's your first 2 ways, first 2 index cards. So the first one is side, 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 SSS. If 3 sides in one triangle correspond to 3 congruent sides in the other triangle, then the triangles are congruent. So do you see how we have 3 sides or 3 pairs that are congruent from one triangle to the other? Okay, so then those triangles are congruent to each other. So if they're congruent, we can write our congruence statement just like yesterday. So congruent statement is saying like triangle what is congruent to triangle what. So I'm going to call the first one triangle WLD. And the reason that I'm picking that way to call it is I like to go down the sides that are marked. So see how WL is marked with 1 mark, LD is marked with 2 marks, and then we go back to W, it's marked with 3. So we've got 1 side, 2 sides, 3 sides. Do the same thing with this triangle. Go 1 side, 2 sides, 3 sides, and our second triangle would be named CAT, C-A-T. So triangle WLD is congruent to triangle CAT. I used to teach at West Oaks, and we were the Wildcats. It's fun. Okay. Now, that one is probably the easiest one to see. You just match up the 3 sides. So the next one we have is called side angle side. And it says if you have 2 sides in the included angle. So you have 2 congruent sides. They come together. Where they meet together, if there's an angle between them that is also congruent, then the 2 triangles are congruent to each other. So as we can see in this picture, we have ME is congruent to OD because it's marked. ML is congruent to OY. And where those 2 sides come together that are congruent, we have the angle. Angle M and O are congruent. And a lot of people use these acronyms to help you figure out what they are. We have a side, an angle, and a side. All 3 of those are in one corner. They all touch each other. So those 2 triangles are congruent by side, angle, side. So let's write our congruent statement. So we would say triangle MEL is congruent to triangle ODY. Way to make a melody. It's fun stuff. Get it? Melody? Okay, great. So those are 2 ways. We have side, 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 side angle, side. So remember, side angle, side is 2 sides and the angle that joins those 2 sides. So now let's look at our 3rd and 4th way. So grab your next 2 index cards. These next 2 are going to pop up in a minute, but they are called angle, side, angle, and angle, angle, side. They might pop up in a minute. They are taking their sweet time. So there's the next 2 index cards to write down. Write angle, side angle on the front. Write the sentence and the picture on the back. And then do the same with your 4th index card with angle, angle, side. These index cards that you're writing today, it's very beneficial to also know the words that it says. So that's why I want you to make sure that you get that sentence down, because it helps explain what the parts are that you're looking for. So the picture is good too, but the words are really beneficial. So let's look at our first one, angle, side angle. It says if you have two angles and the included side. So looking at that picture, it means that you have two angles that are equal to each other and the side that's between those two angles. So here we have PE. Those angles are equal to TY, but also the side from PE and TY are equal. So this one shows angle, side angle. So if we wanted to write our congruence statement, we have triangle POE, which is congruent to triangle TRY. So we have some poetry. Okay, poetry. You know, like Edgar Allan Poe. Poetry. And we're going to try. All right, next we have angle, angle, side. This is the one that a lot of people forget about, but it's two angles and the non-included side. So it doesn't matter which other side you have, but it's not the one that's between the two angles. So the one above was two angles and the side that connects. This one is two angles and then a different side. Now it has to be a side that's in the same space than the other. So we have angle P and C are congruent, angle I and angle O is congruent. Notice the side that's congruent connects with I and O, so it has to connect with the same type of angle for it to work. So these two are congruent by angle, angle, side, two angles and the non-included side. So we'll call the first triangle, triangle pig, which is congruent to triangle cow. So we have pig, cow. Triangle pig, triangle cow. All right, so far we have 4 ways out of the 5. So we had side, 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 angle, angle, and angle, angle, side. If you notice, all of those either have an A or an S in it. And I bet if you think real hard, you might think of a word that has 3 letters that has A and S in it, but it's a bad word, right? Or unless you're talking about a donkey. So, but we don't say that word and we don't write it on our papers. So some people, though, somebody will this semester. Somebody will write angle, side, side, which is not one of the 4 we've talked about. So keep that in mind. Now, the next one is different. It actually doesn't use A's and S's to name it. It uses H's and L's because it deals with a right triangle. And in a right triangle, we have legs and hypotenuse. So we have our first 4 were side, 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 angle, 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 side. And when the board changes, we will have HL. Ta-da! There it is. So this is the right triangles, are also known as the hypotenuse leg theorem. You will hear me call it HL theorem. So write down all the words and draw both pictures on the back of your index card. While you are drawing that, I'm going to pass out your notes for today. It looks like a lot of problems here in your packet. But we're going to go through all of these together because the more examples we do, the better off we are. So HL is our last congruence triangle piece that we have. So it only works for right triangles. So let's just review right triangles a little bit. How do we know something's a right triangle? It's got a right angle, right? Okay, so it's got the little box or the right angle. So if it is a right triangles have two legs, and then it has a hypotenuse. So the hypotenuse is always the longest side, and it's always across from the right angle. So the parts that make the right angle are called the legs. The part across from the right angle is your hypotenuse. So our hypotenuse leg theorem says if the hypotenuse of one triangle and leg of one triangle are congruent to the hypotenuse and leg of another triangle, then the two triangles are congruent. So notice in this picture here that we have this shape ABCD is actually split up into two triangles, right? This bottom triangle is a right triangle because we have an angle at A, and this top triangle is a right triangle because we have a right angle at C. And we have marked that AD is congruent to BC. Well, is AD a leg or hypotenuse? It's a leg because it touches that right angle. So if it touches that right angle, it's a leg. Okay? What about BC? It's also a leg because it touches the right angle. So we have a leg that's showing that it's congruent. We have a right angle. The other thing we need is the hypotenuse. Where's the hypotenuse of this lower triangle? It's in the middle. It's BD, right? Which is also the hypotenuse of this triangle. This side equals itself. This is where we're going to see that reflexive property that we talked about way back when in Unit 1, but this reflexive property will come up. Since they share this line, it's equal to that line, so it's the same. So now we have the hypotenuse that's equal, and we have a leg that's equal, and they have a right angle. So these two are congruent by HL. So let's write our congruence statement. I'm going to call the first one ADB. Now, think about how I named this one. I started at the right angle. So what's the right angle in this other triangle? C. And then I went from A to D. So I went down the leg that was marked congruent. So if you start at C, you're going to have to go to what letter next? B, and then come back to D. So to write the congruent statement for this one, it would be triangle ADB is congruent to triangle CBD. Okay, so mark those things that are congruent so you can write that congruent statement. All right, so again, there are 5 congruencies. I'm going to write them here on the board. I did write them on the whiteboard over here so that way you could see them and keep viewing them. You don't have to write this down. I'm just going to write it here so that way we can talk about it. So the first one is side, side, side. Then we have side, angle, 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 side, and HL. Now, HL is actually, if you look at the picture, it's angle side side. Don't say that word out loud, but think about what it spells. And don't make an angle side side out of yourself by saying angle side side. Get it? Okay. So you don't want to write angle side side on your paper or side side angle. But what I always tell people, if it spells a bad word, it's probably HL. Because if we look here on this picture, we have an angle, a side, and a side. So if you were to kind of say it out or kind of go what goes together, it looks like angle, side, side. So if it spells a bad word, it's probably HL, as long as that angle is a right angle. That's the only way it works. So we're going to do a little chant. So you guys chant it out with me. We're going to say all of this together because the more you say it, the better you remember it. And I don't give you these. You have to know them. So ready? Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. HL. Let's do it one more time. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. HL. When you get your quiz tomorrow, I would write these 5 at the top in the corner. Write them out real quick so that way you have them and that way you know them. Okay, so let's do our examples now. So grab that packet that I gave you, and while you're looking at that packet, I would take your 5 index cards and just line them up at the top of your desk there, so that way you can see them. So we don't have any extra paper, you're just lining them up. You've got your 5 index cards, and you got your packet that we're going to go through together. Does anybody have any questions so far? Okay. All right. So what we're going to do in this packet that I gave you guys with notes, I'm going to have to kind of move up and down on this, but we are going to tell why they are congruent to each other to begin with. So let's look at this first picture. Why is triangle ABC congruent to triangle EFD? Side, side, side. 3 sides in one are equal to 3 sides in the other. So you write side, side, side there at the top. All right, let's look at our next picture. Why is triangle ABC congruent to triangle CDA? Well, if you look at the picture, it's only 2 sides marked, right? How many items do we need? 3. But we can mark 2 things. So put you a little star up here at the top. You can mark shared sides, which would be congruent. And the other thing that you can mark is vertical angles, which are congruent. Now, if you see parallel lines, you know all kinds of things that you can mark from there as well. But the main 2 things that I tell people is if they share a side, you can mark it congruent to itself. Or if you see vertical angles, you can mark them congruent. So in this picture, it shares this side here in the middle, so we can mark it with 2 marks, so it's a little bit different. So now, why are these 2 triangles equal? Side, side, side. We have 3 sides marked in both triangles, so those 3 sides are equal to each other. All right, let's look at question 14. So in this one, we have 2 sides and an angle. Now, if you look at your 5 things that we have, look at your 5 index cards, 2 sides are 2 S's, an angle is 1 A. If you look here, the only thing that has 2 sides and 1 angle is side, angle, side. So is the angle between the 2 sides? Yes, it is. So this one is SAS. S-A-S, side, angle, side. We have 2 sides and the angle that connects those 2 sides. So don't forget, the angle has to join the 2 sides together. In 15, I only see 2 things that are marked. I see a right angle and a side, but these 2 triangles are together, so what else could I mark? The line they share in the middle. So I don't have any vertical angles, but they do share that line in the middle. Now, when you look at this one, it's also 2 sides and an angle, but is the angle between the 2 sides? No, it is not. For that angle to be between the 2 sides, it would have to be up here at C. This looks like an angle, a side, and a side, which if you put those letters together, it spells a bad word, right? Don't want to say that. But what kind of angle is it? It's a right angle, so this is a HL. We have the leg, which is actually the line they share in the middle, and then the hypotenuse, which is on the sides. So the leg's in the middle now, the hypotenuse is on the sides. So this one is HL. If you see a right angle, just go ahead and check to make sure it's HL. Do they have a hypotenuse that's equal? And do they have a leg that's equal? All right, let's look at problem 21. How many things are marked in problem 21? There's 4 or 2 pairs, right? There's 2 pairs. How many pairs of things do we need for any of these? 3. Can I mark a side that they share? Can I mark a vertical angle? Remember, vertical angle's got to make an X. Do we see an X anywhere? No, not completely. So are these two triangles equal to each other? No. This one is a no. We don't have enough information to answer it. It's not side, side, side. It's not side, angle, side. It's not HL. Although we have a right angle, we just have the hypotenuse. We don't know anything about the other legs. All right, what about our next problem here? You can mark some vertical angles. Good job. Yep. You could mark these two in the middle because it does make that X. So you can mark those vertical angles if you need to. Make yourself a note. That way you know what you marked. We had vertical angles in this picture. So is this one of our 5? Which one? It's side, angle, side, our SAS again. We have two sides that come together where that angle is, and those angles are equal to each other because they're vertical. Are there any questions so far? If there's one that you don't understand, raise your hand and just be like, explain that one again, okay? All right, let's look at our next one here. Is there anything that we can mark in that picture? We can mark that line in the middle that they share. Good. Are the two triangles equal to each other? Well, let's look at what's marked. So I have a side, an angle, and then the side that they share in the middle. So this would be side, angle, side again. Or SAS. I love how y'all are like, SAS. It's just SAS. I don't know what's happening to my picture there, but I can fix it, hopefully. Okay, let's look at 23 over here. Is there anything else that I can do? I can mark P and M. Now, notice I already have something marked with 2 lines, so I need to mark MP with 3 lines. So why are those 2 triangles equal? Side, side, side. Y'all are just going to shorten this as much as possible, huh? Y'all are just going to go, they are hissing at me. All right, what about this last problem right down here? What could we do? Mark the middle line. So are these 2 triangles equal? By what? Side, angle, side. The 2 sides that come together right in between them is that included angle. So side, angle, side. Any questions, you guys? All right, well, let's turn the page. Is that what the next page looks like? Yes. Okay, let me go back up here to the top. Okay, so this one, we're doing the same thing on this page. Why are the 2 triangles equal to each other? How can we prove it? So what do you think about number 1, this first picture? Looks like, what? We got the vertical angles marked, so why is this triangle equal to this triangle? Side, angle, side again. SAS again, or side, angle, side, because we have 2 sides that come together to form that angle. Sure. Okay, so this side is equal to this side, right? And then we have this side is equal to this side. And then we have our angle that's in the middle. So if we look, we have 2 sides that come together and that angle in the middle. So that's why it's side, angle, side. Now, question 2 is a little tricky because the triangles are kind of built in with some other things. So I'm just going to highlight them. If we do C, D, E, that's this triangle right here. Okay? Think about what's marked equal in that triangle, or what's just marked. We have the angle at D, the angle at C, and then we have line DC, right? So this is showing 2 angles and the side that connects them. So this would be angle, side, angle. Try not to shorthand and make new words for us here, but it would be angle, side, angle. Now, let's highlight the bottom triangle, which it says ABF up here in the congruence statement. So if I go A to B to F, think about what's marked in that triangle. Well, I have angle B, angle A, and then the line that connects A and B. So these two are equal by angle, side, angle. We have two angles and the side that connects those two angles together. So angle, side, angle. All right, question 3. We've got some that are kind of written together again. They've added in some extra lines in there, but we're looking at DEA. So this triangle here on the left, and angle BEC, which is the triangle on the right. What do you notice about those triangles? They're right triangles. So if they're right triangles, maybe we should check to see if it's HL. Is the hypotenuse equal in both triangles? Yes. So our hypotenuse are these sides here, A, D, and B, C. They're equal. Do we have a leg that's equal? Yes, which would be DE and EB. So these two triangles are equal by HL, hypotenuse leg. These two are actually overlapping triangles in our next picture. So let's highlight those and figure out what's marked. It's usually best to start with like one at a time. So here is AGE. Well, if you look at that, what all is marked in there? Just a bunch of sides, right? So let's look at our next triangle, CDF. Are the same type of sides marked in the same type of way? Yes, so why are these two equal? Side, side, side. All right, let's take a look at question 5. These luckily are drawn separately for us. What is marked? Two angles and a side. So if you look at your list of 5, it could only be angle, side, angle, or angle, angle, side. So is the side between the two angles or not between the two angles? It's not between, so this one would be good, angle, angle, side. We have these two angles and then this side that's not between, so angle, angle, side. All right, question 6. If you only go with what's marked, what could it be? It could be angle, angle, side again. We have two angles and the non-included side, right, in both pictures. This could be angle, angle, side. Or somebody else might look at this picture and say, hey, Miss Cook, you can mark what? The line in the middle, the line that they share. If I mark the line that they share, this could now be not angle, side, angle. Oh, which that's what I thought to begin with. It would still be angle, angle, side though, right? Because that side is not between the two angles. But some people think, well, I could mark some other stuff, so there should be no or there. Sorry, in my brain I was going a little bit different. But yeah, it would still be an angle, angle, side with this. But sometimes if you mark things that they share, it might change it to like angle, side, angle, which is where my brain was going too. So, all right, question 7. Question 7 actually gives you some additional information. If you see that additional information, then you can mark it in your picture. So this one is saying that BD bisects angle ABC. What does it mean to bisect something? Cut it in half. So angle ABC, or really angle B, is cut in half because that bisector. So you can mark that those two things are equal. Is there anything else that you can mark? The line in the middle that they share, right? We could mark that as well. So are these two triangles equal? Yes. Why are they equal? Side angle side is correct. We have two sides, and then this angle connects those two sides together. So side angle side with those two triangles. Does everybody see that? Does that make sense? Okay. All right, let's look at question 8. Anything else that we could mark in question 8? Because I only see a few things listed there. The middle line, we could mark it. And then also notice, maybe you notice this first too, it's a right triangle. So if you see that right angle, is it HL? Is the hypotenuse marked congruent? Is the leg good? So that one is HL. Now, not every time is it HL, but a lot of times when you see that right angle, it is. Okay, let's turn the page. Now, this is pretty similar to what you guys will be doing on your homework tonight. There are actually 3 questions here. So you want to make sure that you answer all of these questions. The first one says, are they congruent? If they are, we write a congruency statement and we give the postulate. So the postulate is one of our special 5. So side, 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 angle, 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 side, HL. HL is just kind of thrown in there. So look at these 2 triangles. Is there anything else that we can do? We can mark vertical angles here at E. This one is equal to this one. Now, just because it has a right angle, is this one HL? No. What makes these 2 triangles equal? Angle, side, angle. You're correct, because we have the 2 angles, the vertical and the right, and then the side between them. So these 2 are equal. First line, we would say yes. Line down here, angle, side, angle. And then in the middle, we write our 2 triangles. So I will give you the first one, and then you tell me the second one. What if I say CED? CED is equal to AEB would be correct. So how you name them is you can match up the angles that are the same. That's the best way. It's the easiest way. C and A are both right angles. E was the vertical angle, so go to the one not marked. So the right angle, the marked one, not marked. And that's how we would write that congruent statement. Does that make sense? Okay. Let's look at problem 2. Anything else we can do here? Mark the middle. I would mark it with 3 marks since we already have 1 and 2. Are the 2 triangles equal? Why are they equal? Good. Let's say I name the first one LEO. Let's name him Leo. LEO would be equal to VEO. Very good. You can also think about how the triangles look. These look kind of symmetric, so go with a symmetric order. Now, don't forget, if it gives you information like number 3, you want to mark that in the picture. T is the midpoint. What does a midpoint do? Splits it in half. So WR is split into 2 sections. I'm going to mark them with 1 mark since we already have something else marked with 2 marks. So WT is equal to TR because it is the midpoint. Now, here we have 2 sides and an angle that's marked. Our only choice would be side, angle, side. Does this show side, angle, side? Is the angle between the 2 sides? No, I saw some of you saying yes and some of you saying no. If it was side, angle, side, the angle would have to be here. It's got to be between the 2 sides that connect. Is that angle in that spot? No. So these are no, and you don't have to answer the rest. This one actually shows angle, side, side, and we don't want to make an angle, side, side out of yourselves. No, no, no. All right, let's look at problem 4. Now, 4 has these little red arrows here. What does that mean? Parallel. When you see parallel lines, you know 4 types of angles. alternate interior, alternate exterior, corresponding and same side interior. You thought they were going away, and unfortunately they are not. They will be here forever. So the ones that I would mark in this picture, though, would be a lot of the alternate interior angles because you have those different transversals. So this angle up here at the corner at E could be equal to the angle at F. This angle up here at G would be equal to this angle here at F, going from the parallel line to the transversal. And we could kind of keep going with angles that are the same. So this angle here on the outside of G would be equal to this angle here at H. Now, it looks like, if we focus on our two triangles, angle, side, angle. But are the angles congruent in the two triangles that you see? We know that these two are the same, but is this one equal to this one or this one? No, so you got to be careful. This one is actually a no because we're not sure about those angles, if they are the exact measurements as the ones at the top and bottom. It's likely that they are, but they could be different. Okay, our next picture. IH bisects angle WIS. Well, we said when something gets bisected, it gets split in half. So remember, when you name angles, look at that middle letter. The middle letter is I. So I is the one that gets split into two equal angles. Is there anything else we can mark? The line in the middle that they share. Are these two triangles equal to each other? By what? Well, now HL, we have to have a hypotenuse and a leg. I see a leg, but not a hypotenuse. Angle, side, angle would be correct. We have two angles and the side that connects them because the side that they share. So let's name the first one WIH. What would the second one be named? SIH. Side, no, because we don't know if this side gets cut in half. We will know it later that it does, and yes, but right now I would just go by what's marked on the picture. What about number 6? We could mark the middle line. So are the two triangles equal? Yes, by what? Angle, side, angle. That's right. We have two angles and the side that connects those two angles. Now be careful when naming these. I'm going to name the one on the bottom, and I like to go by the angle. So I'm going to say ELG. 1 mark, 2 marks, no marks. So how would you name the top triangle? LEU. If you're matching up the angles that are the same, angle E is the same as angle L because they both are marked with one curve. Angle L here is marked as the same as angle E here because they have two curves, but those letters have to switch spots. All right, question 7. We have some more parallel lines, but now we have 2 pairs of parallel lines. When you have 2 pairs of parallel lines, your alternate interior angles are marked a little bit more freely here. So the angle at R and the angle at T, alternate interior, would be the same. Because of these additional parallels, the other angle at T and R are also equal, but they're equal across from each other. Now these 2 triangles also share that line in the middle, RT. So this is again another angle, side, angle. So the first triangle I'm going to name TRU. So TRU. So the next triangle, we got to flip it, so it would be RTS. So we mark it with 1 mark, 2 marks, not marked. 1 mark, 2 marks, not marked. That's how you want to go through and name those triangles for the congruence statement. So with 4, we don't know that these lines are parallel, so we can't go backwards with them. But here, since these are also parallel, then they can cross across each section. So if we also had not that one's not parallel. If we also had this one parallel to this one, we could mark these different angles in different spots because the parallels are the same distance apart, which would make the length apart's the same. But since we don't know these are the same, we can't really go along with everything else that we have because we can't mark them exact angles. All right, let's look at problem 8. Well, problem 8, we have some triangles that kind of overlap with each other and some things that maybe look a little bit different. But you know what we could mark? Some vertical angles, right? We could mark these here in the middle. Got to mark them with 3 marks because we got something else marked. Now, if we want to focus on maybe that top triangle and this bottom triangle and just kind of ignore this side over here, are those 2 triangles equal to each other? Why are they equal? Angle, angle, side is correct. We have 2 angles because of the vertical angle. The side at the angle at V and Y are equal. And then the side that's not between those 2 angles are equal. So these 2 are equal by angle, angle, side. So we could say WV, oops, we don't have a letter here in the middle. Let's plug in a T there. So WVT is congruent to ZYT. My Z went away. So I just added a letter there in the middle to show that those were congruent. Okay, we are going to do this last one. I know that there is a back page, but maybe we'll save it for tomorrow or something. Let's do this one as our last one. Is there anything else that we can mark? The vertical angles in the middle, yes. So all of the angles are marked. Do we have any sides marked? No. Think about these over here. Side, 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 angle, side, angle, side, angle, 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 side, HL. Every one of them we need a side. If we have no sides, can they be congruent? No. It's a big fat no. Okay, so their 4th page that's on here, just save it for tomorrow. We might do it tomorrow. And I'm going to give you guys your homework. Now, your homework is these 2 sheets, but I'm going to add on here, this is going to be due tomorrow before 3 o'clock. So if you need your free period to finish up some of this, you can. Now, tomorrow, what we are going to do in class is we are going to come in and go over a few questions on the homework, just a few, and then we are going to play a game of Kahoot, and then we're going to take a quiz. So you should have some time in class tomorrow to also work on these puzzles and these worksheets as well. Okay? Now, make sure if it says write the congruent statement, that's something like that with all the letters.